So now in this section, we're going to examine the limiting reactant concept, and later we're going to show you how to use this to complete stoichiometric problems where you have to figure out the limiting reactant first to determine how much product can be made. So let's begin by looking at our molecular factory again, where we have a balanced chemical equation for the process, so that we see that the hydrogen to nitrogen ratio to make our ammonia is 3 to 1. That's exactly what's needed. If we have exactly this number of moles, if we have 3 moles of hydrogen and 1 of nitrogen, this will be completely consumed, and everything will be gone, and we will have nothing left over but 2 molecules of ammonia. So I call that the theory. This is our balance. The ratio here is from the balanced chemical equation. Now let's imagine an experiment where we have extra hydrogen. So our ratio in our experiment is a 4 to 1 hydrogen to nitrogen ratio. Just by looking at the pictures, we can see what's going to happen is that the nitrogen here and 3 molecules of hydrogen are going to be consumed. So they're gone to create 2 molecules of ammonia. Any hydrogen that we have left over will be unreacted. So what's limiting us is the nitrogen. This is the limiting reactant. So we can see this from the pictures. You can also do it by comparing the number ratios, which is really what I want you to look at. So this is telling you the following. To consume 1 mole of nitrogen, I need exactly 3 moles of hydrogen. And here, my ratio is this. So to consume 1 mole of nitrogen, I have 4 moles of hydrogen, but I only need 3. So that tells me, by examining the ratios here, that hydrogen is in excess. And that nitrogen, then, is the limiting reactant. So you can just do this by comparing the ratios. Let's examine this again, but this time we're going to add extra nitrogen. So again, here's our recipe for making things. And now in our experiment, we have a 3 to 2 number ratio of hydrogen to nitrogen. Well, that's going to mean if you take 3 divided by 2, that's the same thing as 1.5 to 1. Okay? So 3 divided by 2 is 1.5, so this means the same thing. Looking at our pictures, this is what we imagine would happen. 3 moles of hydrogen, 1 mole of nitrogen would react and be removed from our sample. And we would create 2 moles of ammonia, but now we have excess nitrogen, which would be left over. Okay, so we can tell from our pictures that the nitrogen is in excess, and therefore it's the hydrogen that's a limiting reactant. Once it's gone, you can't make any more product. The reaction shuts down. So we can do this by comparing our number ratios here again. Again, this is telling us in our theory we need 3 moles of hydrogen to react with every mole of nitrogen. And now we see here that, well, to remove a mole of nitrogen, we only have 1.5 moles of hydrogen. We need 3. So this is the limiting reactant. The nitrogen is in excess. So the skill that you need to do whenever you're faced with having to figure out the limiting reactant is first get the number ratio of the reactants from your theory and compare it with the number ratio in your experiment. You can just look at the numerator, right? If the numerator is less than the numerator in your theory, then you know it's a limiting reactant. If the numerator is bigger than the numerator in the theory, then you know it's in excess, then the other thing is the limiting reactant, as we showed previously on the other slide.